Lesson 67 is area. So we're finding area again. The switch this time is its area involving functions of y. So when a function, instead of being y equal and is in terms of x, this is more along the lines of when the function is x equal in terms of y. And we're going to be talking about like bounded with the y-axis instead of the x-axis too type thing. So, review first. Okay, the problems we've done. If we're being asked to find the area between two curves, how do we find the area between these two curves, my f of x and g of x? Top minus bottom, right? So in this case, the top is f of x minus g of x, and it is the integral of that, right? So it's the integral of f of x minus g of x dx. Or, again, I still like the idea of top minus bottom, upper minus lower, however you want to think about it. Now, when we do that, okay, what you've got to think about is that we're trying to find the area in reference to this piece here. In other words, it's the distance between f of x and g of x, and that's kind of a vertical distance. Okay, you've got an upper and a lower. What we're going to change to today is more of this type of problem. Okay, whereas if we try and talk top minus bottom here, what's on top and what's on bottom? We can't really talk upper minus lower here, can we? Okay, unless you turn it sideways. Can I talk upper minus lower now? I can. It's not really upper and lower though, is it? Okay. So, in other words, in relation to the y-axis, we have an upper minus a lower, or a one that is farther from the y-axis and one that is closer to the y-axis. So if we think upper minus lower here, but I turn it properly facing, I'm not going to really be doing that top minus bottom business. Okay, far minus close, right minus left. Okay, so in this case, if we're talking about right minus left, my right one here would be the integral of f of y minus the integral of g of y. Notice those are in terms of y. Instead of it being of x, it's of y. And so notice at the end, I'm going to tack on a dy, because we're going to be working in terms of y today instead of in terms of x. All my integration rules and everything are the same. It's just we're working in terms of y. Okay? So, one other note here. When we go to find our... Oh, here, wait, hold on. For picture's sake, that bar I had drawn up on the previous one, because I'm going the distance from the right to the distance from the left, is now this horizontal bar. Okay? And that's just indicating we're going to be in terms of y. When you set your boundaries, normally, if we're working in terms of x, our boundaries are x values. And I know I remember saying that yesterday. Today, we're going to have to think in terms of our boundary values, our a and b values, being in terms of y. So we have to think the a and b values based on the y-axis instead of x-axis. Just pretend you're looking at the picture sideways. Okay? So, if you can't do upper minus lower, think right minus left, and just do everything in terms of y then. You ready to try it? See what happens? Yes. Not horribly so. I mean, this should not be an all-period lesson by any means. Although I say that sometimes and I get surprise myself. So we should be okay though. Example 1. Find the area of the region completely enclosed by the y-axis and the graph of x equals 1 minus y squared. Okay, we need a graph to look at. We need a visual. And as we think about a visual, this is nicely set up to be x equals, and so it's in terms of y. However, when we graph it, what do we usually think in terms of graphing? Y equals. So we're going to work with this a little bit because I want you guys to see what it is. So if I solve for y, can I add y squared back over and subtract the x? So if I add y squared over, then I have 1 minus x. If you want to be able to plug this into your calculator, you'd have to square root it. If we do the square root of y squared, it's y equals square root of 1 minus x. It's just square root of 1 minus x. When you do a square root in an equation setting, though, it is a plus or minus. I don't know if you guys can tell what this is by that middle equation right there. But if I say y equals x squared, what's y equals x squared? A parabola. So what's x equals y squared? A sideways parabola is what we're going to be looking at here, okay? And this is a sideways parabola moved right 1, and then that negative is going to reverse it, is what's going to happen. Now, can you also grab your calculator, though, and type in this? Cassie's like, all the way. Okay, did we get it typed in? Or are we typing in, or are you just relying on me to tell you what we end up with? Sorry, the look on Cassie's face said it all, like, calculator all the way. So, if you graph it, do I need a graph or you guys got it? Okay. It's a sideways parabola, yes? It's a sideways parabola opening to the left. And where is that vertex at?
1, 0.
Yeah, vertex should be at 1, 0. And that means if it's a typical parabola starts by going up 1 over 1, right? It's a 1, 1 and then a 2, 4 relation. So I'm going to draw my parabola like that. So it's important to know it goes through 1 on the x-axis, goes through 1 on the y-axis, and it goes through negative 1 on the y-axis.
That was really hard for me to go. My hand was on the spiral, and I line just went straight out.
Okay, now, what are they asking me to find here? The area of the region completely enclosed by y-axis and the graph x equals 1 minus y squared. So we have the x equals 1 minus y squared. Y-axis is right here. So what area are we trying to find?
From -1 to 1.
That little half a circle, slice of a parabola, whatever you want to look at it. Okay, and I don't know, do I need to write in? Realize this top half, this was doing the y equals the positive square root of 1 minus x, if you did it on your calculator. The bottom half was doing y equals the negative square root of 1 minus x. Okay, so let's do area. Thoughts on how to do this?
I could draw the other one, so -0 from it, since it's on 0, 0, because the y.
Okay, so if we're doing right minus left, my right curve is the parabola, yes? If we're doing right minus left, it has to be in terms of y. Do we already have that solved in terms of y? Yeah. X equals 1 minus y squared. So my first integral is going to be 1 minus y squared. That's your right integral. And then officially, it's minus the left. What is that left boundary?
0.
Yeah, that left boundary is that y-axis. The equation of the y-axis is x equals 0. And so officially, if you want to, you're subtracting off 0. And then times dy. This is just like when we first started finding the area under a curve. It wasn't between two curves, right? It was the area between some curve and the x-axis. And we always just did the integral of the curve. That's essentially what you're doing right here. Because my x-axis is my bottom, or in this case, left boundary. Now, boundaries. Speaking of, what are my a and b values? What are my number boundaries here?
-1 and 1.
-1 and 1. Now keep in mind, does that make sense? Are those y values? If you think in terms of ordered pairs, this ordered pair right here is 0, -1. This ordered pair up here is 0, +1. You need your y values. So the y values are the -1 and 1. So the integral from -1 to 1 of 1 minus y squared minus 0 dy. And I'm going to put on here just as a reminder, these were y values. It's so easy to revert back to x values. Okay, can we integrate? What is the integral of 1?
Y.
Normally we say x, we're going to say y. Minus, what is the integral of y squared? Add 1 to the power, divide by a new power, 1/3 y cubed. Minus the integral of 0. Nothing. Ignore the 0. And then what do? We evaluate this between -1 and 1. Plug the 1 in, and then subtract, and plug in the -1. So if I do this by hand, which is a good one to do by hand, it's 1 minus 1 cubed times 1/3, so 1 minus 1/3. It's that quantity there, minus parentheses. This time I'm plugging in -1. So when I plug in, it's -1 minus 1/3 times -1 cubed. -1 cubed is going to be -1 times 1/3. So it's minus 1/3, if you will. So plus 1/3, exactly. Okay, clean up however you want. If we do parentheses at a time, 1 minus 1/3, what's 1 minus 1/3?
2/3.
2/3 minus -1 plus 1/3.
Plus 2.
It comes out -2/3, but we end up 2/3 minus -2/3, which is 2/3 plus 2/3, which is 4/3. Because it was find the area, officially we can say units squared.
I was writing all my stuff kind of small because I thought we were about to like.
You got a ton of extra
And
room?
then we have to do a whole bunch. Yeah.
That's right. Better have extra room than to run out of room.
I have like over half of this.
Okay. How do we feel about that? I'd say it shouldn't be too bad. It's just, if it's a graph that you can't really do upper minus lower, is it more suitable for right minus left? And can you, will the equations be in terms of y? Okay, ready to try B? Find the area completely bounded by the graphs of x equals 3 minus y squared and y equals x minus 1. It's not that bad, Jack. It's really not. You don't have to throw things.
At least it wasn't
At least it wasn't that.
Just let me know if I need to duck, okay? Okay. What's the first thing we should probably do here?
Make the y equals x minus 1. Make the x equals into the y equals.
Okay, so when we go to set up the integral, we want them in terms of y. So we want them to be x equals. But we need to have a picture so we know what we're doing. And to get the picture, you need them in terms of y equals in terms of x. So we need them both ways, honestly. I mean, yeah, so let's go ahead and get the graphs. Can you guys graph y equals x minus 1? That'll be a piece of cake, right?
It goes almost straight through the middle.
Now, be specific in how you graph here, because we're going to be looking for intersection points, right? Y equals x minus 1 has an y-intercept of negative 1, and it has a slope of 1. So what's that mean? Over 1, up 1, so it's going to go through 1. If you go up again, up 1, over 1, it ends up going through 2, 1. Does that make sense? And you can keep going as far as you need it to. We could also reverse it. You can reverse it and go down 1, left 1, right? Okay. Now, what about this other one?
3 positive on the x-axis, and then you can angle it back.
Okay. So, realize since there's an x and a y squared, it's a sideways parabola. It is moved right 3, and then the negative does reverse it again. If that's not good enough for you, can you solve it for y and put it in your calculator? If I add the y squared over, it's y squared. If I subtract the x, y squared equals 3 minus x. If I square root it, y equals plus or minus the square root of 3 minus x. You got the picture? It's the parabola moved right 3, so it does go through 3, 0. It's a typical parabola then. So that means from that point you're going to go up 1 over 1 or over 1 up 1 and then over 2 up 4. So if I do this from 3, we're going to go over 1. I keep saying over 1 up 1. It's really, since it's a sideways, up 1 over 1, yes? And so if I go down here, down 1 over 1, I end up with a point right there. And then I would go ahead and do the next set. You need to go up 2, and then 1, 2, 3, 4. On the bottom side, if I go down 2, and then count left 1, 2, 3, 4. That gives me some specific points for my parabola. Can your calculator also find some of those intersection points? Okay. A lot of it comes down to, do you have a calculator for this problem or not? I mean, that's a valid point. Okay. It said find the area completely bounded by these. So do you see the area we're trying to find?
From negative 2 to 1.
So for right now, it's that area right there. I'll come back and talk about the specific boundaries in a moment. Not disagreeing.
Oh.
Okay, so area is the integral. How am I going to set up my integral in terms of the equations? Oh, wait. We're not ready to set it up yet.
There's no x equals.
Okay, so we have one of them to be x equals, right? You have x equals 3 minus y squared. Is the other one x equals? No. To get x by itself, add 1. And so x equals y plus 1. Because remember, it's sideways, so we're working in terms of y. So now, what's my setup with my integrals? Which one minus which one?
The 3 minus y squared over x minus 1. Or minus.
Okay. 3 minus y squared minus the y plus 1. Because it's sideways, so we are doing right minus left. Is the parabola always to the right of the line on this specific problem? Or on that specific edge? Now, boundary values. I need my A and B values. Okay, so we need to know our intersection points. I kind of set up my graph so I'm ready to go with those. But if you didn't, your calculator can help you, right? So my intersection points. The top one is at the ordered pair 2, 1. My bottom one is at the ordered pair -1, -2. So what boundaries do I use? What is my problem in terms of? Since I put y as my problem, my equations are in terms of y, we use the y's. So that means I'm going to be using -2 and 1. Just remember those are y values. Okay, do you want to clean it up before you integrate? Might as well. It's the integral from -2 to 1. What cleans up here that I'm talking about?
3 and 1.
It can be 3 minus 1 is 2. You still have minus y squared, and then it's also now minus y. What? 3. I'm just doing like terms, yes. Because now we only, it's not a big difference, but now I only have 3 things to integrate instead of 4. It's not that you would have had to combine them. I'm not saying that. Okay. What's the integral of 2?
2y.
2y. Minus integral of y squared. 1/3 y cubed. Minus the integral of y.
1/2 y squared.
Add 1 to the power and divide by a new power. So 1/2 y squared evaluated from -2 to 1. Okay, start by plugging in the 1. 2 times 1, 2. Minus 1/3 times 1 cubed. Minus 1/3. Minus 1/2 times 1 squared. Minus 1/2. In the parentheses, minus, and now in the next parentheses I plug in -2. 2 times -2? -4. Minus 1/3 times -2 cubed.
Plus 8/3.
Okay, yeah, -2 times -2 times -2 is -8. It's -1/3 though, and -8, which makes it plus 8/3. And then minus 1/2 times -2 squared. -2 squared is 4. 4 divided by 2, so minus 2. Okay, we've got fractions to work with. You can do this how you want. You can put it all together. I don't know the best option. I'm going to make this common denominator for everything is going to be sixth if you want to put it in terms of sixth. What is 2 in terms of the sixth? 2 times 6 is 12, so 12 sixths. Minus a third is 2 sixths. 3 times 2 is 6. Minus a half is 3 sixths. So for that first part, 12 sixths minus 2 sixths minus 3 sixths. Minus, next one needs to, we might as well go ahead and put it in terms of sixths.
Negative 36.
Okay, so if you want, what is negative 4 minus 2? Negative 6. What is negative 6 in terms of sixths? Negative 36 sixths. So then you have negative 36 sixths plus 8 thirds times by 2 is 16 sixths. And I don't care if you do this a different way. Again, you can do it on the calculator. However, this is doable by hand. It's not impossible by any means. So 12 sixths minus 2 sixths minus 3 sixths. My first parenthesis is 7 sixths minus negative 36 sixths plus 16 sixths. Negative 20 sixths. So I have 7 sixths minus negative 20 sixths, which becomes 27 sixths. And you can leave it as 27 sixths. Technically, it reduces. Divide them by 3. 9 halves units squared. Got it? Good solid calculus problems. As I said, definitely doable by hand. Depending on the problem, you might need a calculator.